Dear students, in this lecture, I am going to demonstrate the data analytic tool called as Weka. Weka is an open source tool for the data analytics. It's a collection of all the machine learning algorithms and the data analytic algorithms for the data mining task. The algorithms can either be applied directly to a data set, or you can have the pre-processing on your data set. You can also do you can also have your own Java code and you can run it on a particular algorithm. Weka contains the tools for the data pre-processing, the classification, regression, clustering, association rule mining, and data visualization. It is also well suited for developing new machine learning schemes. You can go on the weka2.ac.nz website and you can find out the latest version of the Weka. You can also download the Weka manual. You can download the Weka and then you can start it on your machine. I've started Weka in my machine by just typing Weka in the startup menu. I've installed 3.8.4 version of the Weka. Due to some background processes, it takes some time. Yes, this is the logo of Weka. It has been developed by the University of Waikato, Hamilton, New Zealand. Look at here, this is the GUI chooser where you can develop your application in the Explorer, Experimenter, Knowledge Flow, Workbench and the simple CLI windows. Let's first explore the first application called as the Explorer. In the Explorer, you can see that there are total 6 tabs: preprocess, classify, cluster, associate, select attributes, and the visualize. The pre-process tab, which is right now enabled, it is enabled and it is having the background color as a blue. It is the first step in any of the data analytic is to pre-process the data, and that's why in the pre-process option you can select your data file. You can apply the pre-processing technique whichever you want to apply and which would be fit to apply now any of the machine learning algorithm. Next is the classification tab, which is right now not enabled. Once you do the pre-process, then the classify tab would be enabled. The classify tab provides several machine learning algorithms for the classification of your data. To list a few, you may apply algorithms such as linear regression, logistic regression, support vector machine, naive, decision tree, random forest, random tree, and so on. The list is very exhaustive and provides both supervised as well as unsupervised data analytics algorithm. Next is the cluster tab. Under the cluster tab, there are several clustering algorithms provided: simple k-means, filtered cluster, hierarchical cluster, and many more. In the associate tab, you already learn in your theory sessions the a priori algorithm. So under the associate tab, you would find the a priori algorithm, and the advancement of those algorithms are the filtered associator, and the FP growth and the FP tree are available here. Next is select attributes. Under the select attribute, it would allow you to feature selection based on several algorithms such as classifiers, subset retrieval, and principal components, etc. Lastly, the visualization option allows you to visualize your processed data for analysis. As you noticed, Weka provides several ready-to-use algorithms for testing and building your machine learning applications. To use Weka effectively, you must have a sound knowledge of these algorithms, how they work, which one to choose under what circumstances, what to look for the processed output, and so on. In short, you must have a solid foundation of data analytic algorithm to use the Weka effectively in building your applications. So here, in theory sessions, you only learn the pre-processing and the association rule mining. I'm also preparing the video on the classification. So in upcoming lectures, you will also learn the classification also. Today, I'm going to demonstrate the Weka Explorer for the pre-processing and the association rule mining. Look at the first, that is the pre-processing. Under the pre-process, look at here, first is open up the file. Open up the file, that is opening a set of instances from a file. You can choose any of the CSV or the ARFF file to pre-process your data onto that file. You can also have any of the website or the web page that you can work upon. You can have any of the RDBMS, DBMS, or any of the SQL or the NoSQL type of the database, and then you can work upon or you can apply any of the data analytics algorithm on the database directly. If you do not have any of the option, like you don't have the file or you don't have any of the web page or any of the web documents, or you do not have any database, and you have only the features or the attributes that in your mind, and you want to apply some analytics over that. Say for example, I want the student reviews on my lectures, but I only have the student roll numbers and their names only. Now reviews, if I wish, I can write down manually or I can generate manually. So in order to generate the artificial data or synthetic data, you can go for the fourth tab, that is generation of the data. Once you are choosing the file, then you can choose the filter. Let's open up the file which is already there. When I install the Weka, it is there in the data folder. I've installed Weka in the drive. Here you can see that in the data folder, all the files are there in ARFF format. The by default file that you can upload onto this Weka Explorer is .arff and .csv. If you have the database, then you can have the Excel or the Access or the RDBMS or SQL or NoSQL type of database, where any of the MongoDB or the Neo4j or any of the database is allowed. Let's say I want to perform the association rule mining later on. So let me go for the supermarket data. If you want to do the classification, then you must go for the weather data, where you can have the class of the data. Let's say by selecting the supermarket data, which are the attributes? Look at here. Once you have chosen the file, then I'm not applying any of the filter. We are just looking at all the attributes of this data. That is, relation over here is the supermarket, and the total number of instances can be shown here as 4624. Total number of attributes are 217, and sum of the weight is again the same, that is 4627. Look at the first attribute as department 1. Look at this window where the department 1 is the name and the type of the data is the nominal. The missing values of the department is 77%. You look at here, total number of instances are 4627. Out of that, 3580 attributes instances are missing for the department 1. Unique value is 0. What is the label, what is the count, and what is the weight that is mentioned here. If you want to see the class total, if you want to see the class department 1, you can see that total 1047 values are present out of the 4627 instances. Again, look at the department 2, department 3, department 2, 97% of the data is missing. Department 3, these are all the department values: baby needs and bread and cake and baking needs, and the coupons and juice and the tea. So these are all the total 217 attributes, and the missing values are more here. The reason that whichever the attribute is present over there, T is mentioned. Look at, if you want to see the whole database, you can, by clicking the edit, you can see the department 1, first department is not present, department 2 is present, but the information is not there. So here you can manually change the missing values by just clicking on the values. Over here, if the department 1 is not present, you can put the T over here, or you can put the missing as it is the space. So here you can also add the instances, also change the values. So manually you can handle the missing values. Now look at here, which type of the filter I should apply so that I want this missing values as 0. Let's say choosing filter. Here Weka is having filters as supervised and the unsupervised filter. See, as I told you that in order to use a Weka, you must have the theoretical or the background knowledge to use any of the method available here. Let's say here merge nominal values, discretization, or the nominal to binary. Each of the value is having the method associated with the help. Look at here, it is once attribute values have been merged in the merge nominal values, the information is given here as a help, that once it is the merge, a chi-square method or the test on the Bonferroni correction is applied here. Nominal to binary, when to apply, how to apply. So all those things are present for the supervised. Let's say go for the unsupervised. There are in attribute, let's say I just want to find out, I just want to remove. As you know that by removing also, by applying the remove also, you can handle the missing value. But you know that what are the pros and cons by applying the removing or by just deleting a particular instance. So by applying the remove, by applying the finding the mean value, by finding the measures, randomize, remove false, non-sparse to sparse, these are all the available filters for the pre-processing. Now whichever the methods you can apply it. Let's say we are going to apply here, we are going to apply replace missing values. See, replace missing values by a unique constant, by the user constant, replace missing values, replace with missing values, string to word vector, swapping, all those things are available here. Here, by selecting any of the pre-processing technique, let's say We have chosen the department 1 where the missing values are 3684. There are various techniques available, as I told you earlier, that is replace with missing values, replace missing values, reordering, discretization, standardization, chi-square test. All those things are available here. Let's say we are going for the replace missing values. So by just selecting the replace missing values, by just left click or the by just clicking it on, we can find out the information for what the replace missing values stand for. Replacing all missing values for the nominal and numerical attributes in a data set with the modes and the means from the training data. Here you know that any of the data analytic model is having the training data set as well as the testing data set. So from the training data set, it would find out the modes and the means, and it would replace all the missing values with that. Okay. If we want to see which are the options available for the replace missing values, you can see here the debug over here. It if it sets to true, if it sets to 1, filter may output additional information. If we are enabling do not check capabilities or the ignore class, what would happen? Or if you want to check all the things in detail, you can click on the more button and you can find out what is the class name, which what are the synopsis, and what does it mean debug, do not check capabilities, and ignore class, for what they stand for. Okay, if you are changing it, then also by just changing you can save it and you can apply it. Let's apply the means and mode, and you can see that the missing value, which was initially 80% for the department 1, is now changed to the missing as 0. If you want to see the data set where the department 1 is having all the values, now you can see that initially it was the missing values, but now you can see that it is having the value as t. For the department 2, for the department 3, all of this we have already applied. If you want to select a particular attribute where you want to change the date name or date, you want to change the format, then everything is available here in the choose. You can have the changing of nominal to string, nominal to binary, number to date, numeric to date, number to nominal. All these things are available. So this is what the standardization of your data set before applying any of the method, or we are pre-processing in order to get the more accuracy in your model. So here you can see that by selecting all the attributes, or by selecting none of them, by just inverting it, or by just finding the pattern of that, enter a Perl regular expression. Regular expression is the expression by applying the few of the characters, like plus e stands for the union, then the star stands for the multiple recurrences of a particular expression. Right now we'll not go into detail of the Perl regular expression, but if you know the language Perl and if you know the regular expression, by applying regular expression you can find out the pattern, and you can only working on those attributes. Here if you want to see visualizing all the classes, all the attributes 217, you can by just clicking on the visualize all, because right now it is total, it is taking some time. Now you can see here the visualization of all the attributes 4627, 217 attributes you have in total instances. You can visualize the class value over here. Over here the class is only, let's say, department 216, and if you have the class department 212, or whatever the department that you are selecting over here, and the class value selecting here, based on that you can visualize the total spread or the dispersion of your values of your instances. Okay, so now our first task is done, pre-processing is done. We have just edited, or we have just pre-processed, applied a filter by just applying means and the modes of the values with the missing value, replaced missing values with the means and the mode. Now let's go for the next task, that now you can see that the classification, clustering, association, selection of attributes, and the visualization is enabled now. As we do not know right now what is classification and the clustering, let's go for the association first, and then we'll definitely we will move for the classification and the cluster also. Let's click on the associate. Only one algorithm that we are know, that is a priori algorithm. We can go for the technical details of the filtered associator and the FP growth. Once we know that, we can also apply on the same data set, and we can find out the result, and we can do the comparison of the algorithm a priori and FP growth on the same data set. Whether a priori gives you the better results in some amount of time, or on what amount of time a priori gives you the results or more accurate results. So based on a different categories, you can compare all the algorithms available here. Let's go for the a priori algorithm. See here, once you are choosing the a priori algorithm, you can change all the parameters. Parameters over here is first is the car, class index, delta, do not check capabilities. All these things you can check from here. The car is what if in enabled class association rule. CAR is the class association rules. They are mined instead of general association rule. Okay, so by keeping this thing, by changing this, suppose you want the number of rules as 10. If you want to change the by keeping the a priori algorithm as it is, I'm not changing any of the parameters, and you can see the results are generated. What are the results? The scheme I have used is the a priori algorithm, where the number of instances, or whatever the number of rules I want is 10. I could change the number of rules also. I could change the minimum support. I could change the minimum threshold also. I have not changed the default values. Default values remain as it is. If you want to change the default values, you can go into the detail of each and every parameters available here, and you can change it. Let's say, let's discuss the results of the a priori algorithm. As I've already discussed, the number of instances used for the analytics are 4627. Total attributes are 217. By minimum support over here, by default is 0.15. That means total number of instances, if you take 694, would be your minimum support, and minimum confidence is 0.9. If you want to change it to the 0.60, you can change the minimum support. You can change it to the 0.50. You can change the number of cycles performed. Number of cycles performed, that means the number of iterations performed over here is total 17. Let's say L1, that is one candidate or the one frequent items generated from the whole data set is 44. From the 217 attributes, 217 items, we get the L1 as 44. and size of the L2 is 380, size of L3 is 910, then a size of L3, L4, L5 and L6. There we stopped. That L6 we got as only one, so it cannot be further computed for finding the L7. And based on the L1, candidate C1 is being generated. Based on L2, candidate 2 is being generated. Rules, best rules found are biscuits equal to T and frozen foods equal to T and fruits equal to T, then total equal to high. This are, if these are the items present in my basket, then bread and cake is being purchased together, that is 723, and the rule is having the confidence as 0.92, that is above 0.9. And over here there are three more terms like lift, leverage and convolution. So we are not discussing, or we are not going into detail, as I have not discussed these terms in the theory, but you can see that the confidence, according to the confidence, we put these things into the rules. So, we found 10 rules. As in the parameters, I have only mentioned 10 rules to be found. So, this is what the output of the a priori algorithm. Similarly, each and every other rules, you can go into the detail and you can find it out. The same algorithm, if we are applying with the FP growth or the any other associator, filtered associator, then what are the results we are getting, and we can change, we can just do the comparison based on the results being retrieved from all of the algorithms. Whatever the results we found, we can go for the visualization of the same. Right now the visualization is not present. It is actually the x-axis is the department 1 and the y-axis is total, so only two parameters are I can see, but as it is very small, it might be not visible. So visualization is also been possible once you generate the results. So here, this is what the output of the a priori algorithm. Let's do the classification now. Classification over here, let's say choosing the classification as how many classifiers are available in the Weka. You can see that it is the base classifier, the functions, lazy classifier, the meta classifier, MISC, rules classifier, and the trees. Again, under the trees, you have the decision tree, Hofiding, J48, LMT, random forest, random tree, REP tree. These are all the classification algorithm under the tree. For the rules also, decision table, JRIP, 1R, part, 0R. These are all the algorithms available under rules. We'll go for the basic classification method called as a naive-Bayes classification. Let us apply for the base also. We have here Bayes Nate, naive-Bayes classifier, naive-Bayes multinomial text, and naive-Bayes updatable. Let's go and choose the naive-Bayes algorithm. Here, by choosing this, you can uh, change the batch size by whether you want to debug it or not. Displaying mode in old format. Do not check capabilities. Number of decimal places. Use kernel estimator. Use supervised discretization. If you want to change this by default parameters, of course you can change it and you can save it. Let's say um, first of all, any of the classification or the clustering model needs the training set. From the overall 100% of the data, let's say 70% of data, you are going for the training set. So training, you will start and then you will supply the test set, and then you will find out the accuracy of your model. Right now we are not doing the training and testing, we are just applying the naive-Bayes algorithm on given data set. Over here, what is the output class? That is, let's say, total. We are just starting it. Sorry, it's a problem evaluating classifier. No user test set has been specified. Okay, it is mentioned that the supplied test set. So we do not want to go for that. We do not want to supply the test set. We are just doing the cross validation fold, where it will do the n fold cross validation, where you can have the folds as 10 or 5 or whatever you wish. By default it is 10, so let's say go for the 10 fold. And we built the model. The time taken to build the model is 0.01 second. So one of the comparison parameter for the more than one algorithm is how much time is taken by your model and what are the accuracy of your model. So first of all, the naive Bayes classification requires 0.01 seconds for this particular algorithm. Then cross validation is started, and then we find that the correctly classified instances are, what is the accuracy? 63% instances are correctly classified and incorrectly classified instances are 36%. So still we need some further or improved version of or improvement in my classification method, where I want the more accuracy, that I want to lessen the incorrectly classified instances and I want to improve the correctly classified instances. Here you can also see the mean absolute error. You can find out the root mean squared error, relative absolute error, root relative squared error on a particular data set. Now, in order to derive the confusion matrix for the classification, you must know that the true positive rate and what is the false positive rate. Here you can see that the 63.7 is a true positive rate and the false positive rate. Precision is not able to calculate, recall is 63.17. ROC region um, uh, uh, under the curve is 0.499 and PRC area is 0.537. So this is what the classification, this is what the confusion matrix, that 2948 they are the correctly classified and 1679 they are the incorrectly classified instances. This is what you can see here, how your algorithm has worked, and uh, for each of the department, what is the low value and what is the high value of the class. When it is the number or the nominal values, then it is highly required that what is the minimum value and what is the maximum values. Dear students, similarly, you can apply the clustering and other algorithms of the classification and the association rule mining also. You can also explore the pre-processing techniques and discretization and normalization over here on your particular application. Hope you like this particular demonstration on Weka. You can also explore the different tools available for the data analytics like Orange, or you can also explore the R or the Python code which is available for the classification and association rule mining as well as for the pre-processing. But this type of tool would help you out in to relate the things which are which are exist, which does exist without coding. That is only by just clicking on a particular algorithm you can see the results and how to relate this concepts with the theoretical knowledge. Hope you like this video. Thank you.